Okay, this video is we're going to prove the alternate exterior angles theorem, which says if two parallel lines are cut by a transversal, then the pairs of alternate exterior angles are congruent. Now this proof is almost exactly like the last proof. So this is the setup, right? We got L congruent to M, and I just changed kind of the numbering of the angles around a little bit. But what we want to show is that these two guys, which are alternate interior angles, or alternate exterior, excuse me, are congruent to each other, okay? Now, if you're looking at saying, if you look at 1 and 3 and you're like, oh, well they are congruent because the alternate exterior angles theorem says they are. That's what we're trying to prove. So you can't use a theorem to prove that 1 is congruent to 3 because this is what we're doing to prove that theorem to begin with. So you can't use a proof, or you can't use a theorem in the proof of the theorem. It doesn't work like that. So this is the setup, but what I want you to do right now is just stop the video and see if you can do this on your own, because I bet you can. If you look at the previous example, the previous problem, this proof is really, really similar. So stop, try it on your own, and then come back and watch the rest of this so you can see if you got it right. Okay, but make sure you come back and check. Stop. Did you stop? Do it on your own. Okay. All right, so I'm assuming you stopped and you did this. Let's go ahead and finish it up. Okay, so we're going to start with L parallel to M given. Okay, now what we know is if these are parallel, then we know that these have to be congruent to each other. 1 has to be congruent to 2. The reason why is because they're corresponding angles, and we have the corresponding angles theorem. We can use that now. We talked about that in the first video. So we can say angle 1 is congruent to angle 2. Corresponding angles theorem. I'm using the angle symbol there. You can too if you want to. And then kind of an abbreviation for theorem. Now you could also have written this. Okay, but if you're going to use like the transitive property of equality, which I'm going to use in a minute, the ordering of these numbers is important. So this is still true, right? And the symmetric property of congruence says that either way you write it, it's fine. But we kind of want to write it the first way so that we don't have to use the symmetric property of congruence later. So we know 1 is congruent to 2. Okay, what do we know about 2 and 3? Well, those have to be congruent to each other because they're vertical angles, right? So again, we're using the vertical angles theorem. Angle 2 is congruent to angle 3, vertical angles theorem. Okay? And then we can say, therefore, angle 1 is congruent to angle 3 by the transitive property of congruence. Okay, you could also use right here a theorem that we proved, which was, we called it the corresponding angles theorem, where if you have two angles congruent to the same angle, then 2 is congruent to 1, but also 2 is congruent to 3. And you can say that both of these have to be congruent by the congruent angles theorem. The difference is transitive property only works when you have the right ordering. So 1 goes to 2, 2 goes to 3, therefore 1 goes to 3. Okay, so it has to, the end of the right side of the first statement has to be the left side of the second statement, and then you can do that. So that's kind of how you prove that one. And very, very similar to the last one.